Good morning and welcome to another day of class. Today's agenda, from 8 to 8:20, please watch the video, and then from 8:20 to 9 a.m., I'll see you on the Zoom call. So put down any questions that you may have as you watch this video, and I'll answer them when I see you at 8:20 a.m. Yesterday, we began Unit 7, which was the introduction to probabilities. And we look at how to find simple probabilities, such as flipping of a coin. Today, we want to continue by learning how to construct sample spaces. So what is a sample space? From yesterday's lesson, we said a sample space consists of all the possible outcomes. All possible outcomes. That is a sample space. There are some that will be easy to construct and there's some that are difficult to construct. So today, we want to learn about some of the techniques that we can use to construct them. So the learning objective today, to learn the different methods used to construct sample spaces. And then 2, to learn how to identify events from sample spaces. So those are the learning objectives for today. Now, but before we do that, let's quickly go over some key understanding from yesterday's lesson, the intro to probability. Now, the probability of an outcome E in a sample space S is the number P between 0 and 1 that measures the likelihood that E will occur on a single trial of the corresponding random event. So in the probability of any event lies between 0 and 1. You cannot go below 0 and you cannot go above 1. It should lie between 0 and 1. Okay. So if you have the value P equal to 0, that is the probability of 0. This corresponds to the outcome E being impossible. And the value P equal to 1 corresponds to the outcome E being certain. Right? So if you get probability of 0, it means that event is impossible, will not occur. Okay? And if the probability is 1, it means the outcome is certain. You're 100% sure that this event is going to occur. So that's P equal to 1. The probability of event A is often written as PA, as we saw yesterday, probability of the event A occurring, right? So if you think about yesterday's lesson, we wrote for the probability of a head occurring, we wrote PH, or P of the head occurring, or P of the tail occurring, PT, and so on. So that's the notation. If the probability of A is greater than probability of B, then event A has a higher chance of occurring than B. And if the probability of A is equal to probability of B, then the events A and B are equally likely to occur, right? So these are some of the key understanding from yesterday's lesson. Right, so let's move on to today's lesson. Methods used to construct sample spaces. The first method is the list method, where you list the outcome. You just list them. And this can be used for simple problems. For example, the coin, if you toss a coin, just a coin, it will be easy to list the outcomes. Or sometimes if you toss 2 coins, it will be easy to list those outcomes. Okay. Then it will be too difficult for other questions, which we'll be seeing very soon. And then they have the tree diagram, and then we have the table method. So these are 3 methods: list, tree diagram, and the table method, right? So example of the list method, for example, example 1, construct a sample space for the experiment that consists of tossing 2 coins, right? This will be, a list method will be easy to do with this. tree diagram looks like this, right? And it will work out for a question like this. Construct a sample space that describes a three-child families according to the genders of the children with respect to birth order. Then identify the outcomes that comprise each of the following events in the experiment of selecting a three-child family at random. So we'll look at some questions based on this soon, but this is how the tree diagram will look like. And then the table method can be used for questions like this, where you roll a die, two dice. So Amina rolled 2 dice during an experiment. Construct the sample space for this experiment. So in this case, you can use a table like this to generate the sample space, where you have the die on one column, and then the first die on one column, and the second die will be horizontal, or the top row of the table. Okay. So we'll look at this in detail soon. Great. So let's look at the details of what I've just discussed. So let's begin with the list method. So construct a sample space for the experiment that consists of tossing 2 coins. We saw this question yesterday, right, where we just listed the different outcomes. Right. So if I toss two coins, what will be the sample space for this, for 2 coins? So the sample space S will be, the first coin could land on the head, and the second coin could land on the head. So I can have 2 heads. Or I could have the first landing on the head and the second landing on the tail. So HT. I could have the first landing on the tail and the second landing on the head. And then the first landing on the tail and the second landing on the tail. So this would be my sample space for tossing 2 fair coins, right? 4 different possibilities. Okay, so this is a listing method. It's easy to just list this when I have the 2 coins. Easy to list. Okay, but when you have the second example, where you want to construct a sample space that describes all the 3-child families according to the genders of the children with respect to birth order, then identify the outcomes that comprise each of the following events in the experiment of selecting a 3-child family at random. Say at least 1 child is a girl, then 2, at most 1 child is a girl, and then C, all children are girls. D, exactly 2 children are girls, and E, the firstborn is a girl. Yeah. Now, join me as I go through the thinking process to draw the tree diagram. 2 of the outcomes are 2 boys and a girl. You can have 2 boys and a girl, which we might denote as BBG. You can say BBG, right? Let's use lowercase for boy, and then uppercase, a lowercase for girl, of G for girl. So B for boy, lowercase b for boy, and G for girl. So you can have 2 boys and 1 girl, or you can have a girl and then 2 boys, which would denote like GBB or GBB, yes. So clearly there's many outcomes that you can have here when we try to list all of them, but it will be very difficult, to be sure that we have found all, unless we proceed systematically. Okay. So the tree diagram can help us do this systematically. We want to approach this systematically by using the tree diagram. Okay. So let's see how to do this. So I'll start with the first order. Okay. So the first order, we use these lines. The lines are called the branches. And then wherever they end is the node. So the line segments are the branches of the tree, and the right end point of each branch is called the node. Okay, it's called the node. And then the nodes that will be on the stream right will be the final nodes. Okay, and those will correspond to the outcomes as we saw in the previous picture on the video. Okay. So let's start. So the first order can be a boy, or it could be a girl. You have a boy or a girl. Now, what are the second order, birth order? The second birth order. So the second birth order, if it's a boy, right, then the second birth order could be a boy or a girl. Those are two possibilities that can occur for the second birth order. Now, the first birth order is a girl. What are the possibilities? You could have a boy, or you could have a girl. Second birth order. Then the third birth order, because there are three children. So first born, second born, and third born. So the third born order, if the second is a boy, what are the possibilities for the third order? So the third order, this could be a boy, or it could be a girl. If the second order is a girl, then you could have a boy and then a girl. The same thing here. If the second born is a boy, the third born could be a boy, or you could have a girl. Then if your second born is a girl, you could have a boy or a girl for the third order birth. Okay. So this will be the tree diagram for this question. So how do you read the outcomes? Now, to get the outcomes, you follow the branches and the nodes. Okay, so we get to the final node. This is the final node here. Okay, the final nodes. So this is how I'm going to read it. So the outcome for the first outcome, we have boy, boy, boy. So write it down. It could be a boy, it could be a boy, and a boy. So that's boy, 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 right? Then the second outcome could be a boy, boy, and girl. So it could be a boy, and girl. Okay, do the same thing for the third outcome. So you could have a boy, girl, and a boy. So boy, girl, and boy. Now what about the fourth node? The fourth node will be boy, girl, girl. Okay. Then what will be the next one? So boy, girl, boy, boy. So it's a girl, boy, and boy. Then the next outcome, girl, boy, and girl. Girl, boy, girl. Okay. Now the next one will be what? Girl, girl, boy. Girl, girl, boy. And the last outcome will be girl, girl, girl. Right. So it is using the tree diagram, we can systematically come up with all the possible outcomes. It will be difficult to do this without the tree diagram. You see, the listing method will be difficult to use to do this, because you're likely to miss one of the outcomes. Okay. Great. So these are all the possibilities that you can get when you use a tree diagram, all possibilities. Okay. Right. Now, starting tomorrow, we'll be calculating probabilities based on this tree diagram. But for today, we just want to list the possible outcomes. So let's use this information to answer the questions above. Okay. So the first question says, at least one child is a girl. At least one child is a girl. So if you go to possibilities, we're going to look for at least one child. What's the meaning of at least one child? At least one child means that one or more. One or more. That's what at least means, right? So let's write it somewhere here. So at least, it means one or more, right? So we have one or more of the children, it's a girl. So out of this list, which one do we have to choose? So let's go through the list. I need at least one, so with one or more. So this is one, right? One of this, that's one. Two, so let's list that as we go on. So the sample space, sorry, the event here, the event you're interested in is this B, B, G. That's one. Then you have B, G, B. What else? If you look here, at least one, so two. So that's also part of it. B, G, G. Okay, this is one. Then at least one. This is G, B, B. At least one. G, B, G. Then you have another one here. G, G, B. And all girls, G, G, G. So this will be the event for getting at least one girl. At least one girl. So that's what this is, at least one. Okay. Now, what about at most? So this is A. And what about B? B, we want at most one child is a girl. At most one child. What does it mean of at most? At most, it means that the maximum that you can have is one child being a girl at most. At most, so max. Maximum of one. So from the list, which one will give us maximum of one? So we go through the list again, the sample space, maximum of one. So this is from here. So B, B, G, max of one, another one here. So you have B, G, B, maximum of one, that's G, B, B. And then that's it. We don't have any other one again. So three possible outcomes to get maximum of one, right? And then what about C? All the children are girls. So C, all the children are girls. Which one will give us all children girls? It's right here. Okay. All children girls. So the event that you have all girls will be G, G, G. All of them are girls. Okay. And the last one, D, sorry, last but one, D. So D, exactly two of the children are girls. Exactly two are girls. So which one gives exactly two? If we go through this, we have exactly two. This is one. So event B, G, G. So exactly two. We have another one here, exactly two. So G, B, G. And then another one, exactly two. So G, G, B. So those will be the events where you have exactly 2 are girls. And then the last one, which is E, says the firstborn is a girl. The firstborn is a girl. So for the firstborn to be a girl, let's go through the list. So this is the firstborn, the first row, right? So which one will give us a girl? So I have girl here, girl there, girl there, girl there. So all this will be the event. So event E, all girls. Sorry, the first is a girl, so that's G, B, B. And then this will be G, B, G, first girl, G, G, B, and then first girl, G, 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 right? So this will be the outcome for having firstborn as a girl, right? So you see how easy it is to use this tree diagram to answer probability questions like these. Okay, this will come more handy when we start working out the actual probabilities themselves. Great. So we'll take 30 seconds to look at this diagram again. If you have any question, I'll see you on a Zoom to discuss this. Right. Great. So the last example I want to look at is the third question, which says, Amina rolled 2 dice during an experiment. Construct a sample space for this experiment. So the two dice experiment is easy to use the table method to come out with a sample space for this, right? So track how I reason through this problem. So to do this, you write the first possible outcomes for the first die here. So first die in this column. And then we can, the second die, the outcome in the top column here. Okay. So what are the possibilities for the first die? We have 1, 2, 3, 4, 5, and 6. And then we also have possibilities for second one, 1, 2, 3, 4, 5, and 6. Okay. So the first could land on 1. So we're going to write 1 and then comma and then 1. Second die will be 1. The first could be 1. So when I come here, the first could be 1 and the second could be 2. So we can have 1 and 2. And if you come to this column, the first row, the first die could land on 1 and the second one could land on 3. So it's 1 and 3. Or we could have 1 and 4 and so on. Right? 1 and 5. First could be 1, second could be 6. Okay, so keep going till you fill out this table. So first that could land on 2, first could be 1. So you have 2 and 2. 2 and 3. 2 and 4. 2 and 5. First 2, second 6. First 3, and then 1. 3 and 2. And then 3 and 3. 3 and 4. First 3, second 5. And then 3 and 4. Sorry, 3 and 6. And so on. So we can keep going and then we can fill up all this table. So once you do that, we'll come up with a table that looks like what we have here. Okay, it's going to look like this. Okay. So this is a 2-die sample space. Okay, we come up with a table like this. Okay. All right. So I'll end here for now, and then I'll see you on the Zoom call for more questions and independent practice. See you soon.